Hi, everyone, and welcome to today's webinar on the importance of modelling. My name is Arthur Moore, and this webinar, alongside with Tutorful, is all about the importance of modelling. Modelling is such an important part of our journey as an educator, as a tutor. It's something we really want to focus on. Just a reminder for everyone who has joined live. Thank you for everyone who has joined live. There is the chat function is open. The Q&A function is open. So please do go and ask me plenty of questions. I've got plenty of points where we can ask questions in the session, so I will come to those. Or you can just ask them and I can see them in the chat and we can come to those. You can message me directly or you can use the Q&A function. Right, let's get going very quickly. Just for those who have joined for the first time or who are watching as a recording, hello, people watching as a recording. My name is Arthur Moore. I am an online maths tutor. That is my full-time job. Before then, I was a secondary maths teacher and have taught in schools across the UK and internationally. I've taught in a range of schools, state, private, all through boarding, international. I've taught in a full range of schools. My outfit for tutoring is called More Edu, which you can see the logo on my jumper there. I also run a tutor CPD platform called Navigated Tutor, where I help tutors develop as teachers and as educators by staying up to date with the latest pedagogical knowledge and cognitive science. I, in 2024, won Tutor of the Year from the Tutors Association, and Navigated Tutor has been shortlisted many times for a full range of awards, and this year was shortlisted for Educational Resource for Tutors. Right, that's enough about who I am, so we can get going. So, the aims for our session today are to explain why models are important. They're such a fundamental part of what we do as tutors in education that's really important we understand why they are important. And we're also going to discuss how we can develop our modelling to increase their impact on our students, which is what we are all about. So, firstly, I just want you to think about the teacher-student dynamic. So, especially when we're working one-to-one, which I know people on this call do via Tutorful, that is the really key dynamic that is going on. And that dynamic, whether it's in the classroom, as some of you may have been, or face-to-face at some point over someone's kitchen table or online, that is the real key dynamic in this whole learning process. And what we need to remind ourselves is that we as the teacher, we are the expert. And I'm going to keep referring to us as that. Now, sometimes we don't like to use that phrase. We feel really weird to use the word expert. But in your subject area, when you're teaching your students, you are absolutely the expert in that teacher-student dynamic. The student's what we refer to as the novice. They are the person with less knowledge in that area trying to learn. So when we need to be comfortable referring to ourselves as experts in this dynamic. It's a really important thing that you take a moment to say to yourself, do you know what? I am an expert in this, especially in this dynamic. It's like when you go, if you then go to a talk about, if I went to a maths conference, that student teacher dynamic changes. I become the novice in that situation. But in this situation with my students, I'm very much the expert. And what we aim to do is we are aiming to transfer knowledge from the expert to the novice. That's what we're trying to do in these sessions. If you think about it really, really crudely, we are delivering content and we hope that content in the form of knowledge is going from us as the expert to our student, and our student takes that knowledge. There's a really important idea there to feel comfortable with. Now, the problem here is that we as the experts can't remember what it's like to be a novice. I spoke about this briefly in some of the other webinars. Let's just talk about this a little bit more. When you are an expert in something, you have learned something. You have knowledge in your brain, in your long-term memory, that you are able to access. Now, it's very, very difficult to not access that knowledge if you have it. It's very hard to imagine what it's like not to have that knowledge. For example, if I asked you to remember what it was like to not be able to ride a bike, that is incredibly difficult. It'd actually be really hard for you to get on a bike and just fall over because you just don't have that knowledge. Think about throwing and catching a ball. It's very hard to have that dynamic. When we are working with our youngest students, if anyone watching this works with kind of early year students with phonics and stuff like that, it's really difficult to remember what it's like to not be able to make certain sounds with our mouth. You'll find this when you learn another subject area. This is why I always have so much respect for MFL teachers. I think they're absolutely incredible in what they do because they are constantly changing that dynamic. They are very much working with novice, sometimes in the purest sense of that word. If you think about when you try to learn a language, you have to start right back from the basics. It's a really good way to think about kind of that expert novice dynamics, what it's like when you want to learn a new language. Now, the way we solve this problem is the novice watches the expert do something. And by watches, I mean, it might be from them writing, might be from them doing, it might be from them speaking, but they observe the expert. I like to think about this in terms of kind of like a recipe book. So you get your recipe book. Now, when I'm trying to make something for the first time with my recipe book, I'm very much the novice, and my teacher, in this case, the book or the author of the book, is trying to give me knowledge. And I observe what the expert is doing in that moment. That may be in the form of some pictures, maybe in the form of some written text. It may be in the form of a video if I'm watching a YouTube channel. But when I'm first making this recipe for the first time, I have to very clearly follow that recipe because it is new information to me that I am trying to learn by observing the expert, the video, the recipe book, the watching my mum or dad cook, for example. So the key thing to think here is you can't expect your novice learner, the student, to do things without guidance from you as the expert. And this comes in the forms of models and worked examples. So if I go back to the idea of a recipe book, if I just said to you, make this thing that you have never made before, it would be incredibly difficult, almost impossible for you to just go, I'll kind of just figure it out. This sauce, make that sauce. I don't know any of the ingredients to go into it. I don't know the processes. I'll just try and figure this out. Think about baking, for example. You have to be really precise for baking. You have to know the right ratios, how much of something to use in respect to something else. But if you don't know those ratios and you just go, well, bread kind of has some flour and water in, I'll kind of mix loads and loads of water with a bit of flour, then you're not going to get the outcome you want. What I need is a bit of guidance from my expert. And this guidance comes in the form of what we would call models and worked examples, which is what I'm going to talk about for the majority of this webinar today. So the first thing I want to talk about is modeling. And I think this quote from Jade Pierce's brilliant book, What Every Teacher Needs to Know, is really important. We know from research that this idea of partial instruction is ineffective for novice learners. We know it's not a good thing to say to novice learners, and think about what I'm using by that word novice, I want you to kind of do this. It's a very ineffectual way of teaching. What modeling does is it allows us to make these new skills, these challenges accessible because we are allowing the novice to observe us as the expert at each of the stages. Again, think about that recipe book, or if you watched a video on how to change a tire on a car, you would watch it and clearly watch each step and follow each step. You wouldn't just read the ingredients list and try and make the dish. Again, you're a novice in this expert. I'm not saying something you know how to make. And the model is the absolute central feature of a good explanation. And that's from Tom Sherrington's blog online about exploring Rosenshine's principles of instructions. And I really like this idea that it's the central feature, and we need to put that at the absolute essence of what we are doing as the tutor. So what I'm going to talk about now is some ideas that can make your models even better, and some of the key ideas for it. The first thing I want to talk about is think aloud. Now, this is a really, really crucial part of the modeling process. When I think aloud, I externalize my knowledge for the student to access. Again, if we think about this in terms of making a recipe, if I just put some ingredients in a bowl, mix them up, do something with them, put them in the oven, fry them, whatever, my student is only kind of understanding what is going on. And the reason they're only kind of understanding what is going on is because they are struggling to access my thinking as the expert. We think back to that diagram where the novice is observing the expert. We need the expert to be showing every step of the model, including that kind of inner monologue. I just want you to take a time to think about the last tutoring session you taught, whether that was earlier today, yesterday, or next week. I've got a tutoring session coming up later this afternoon, for example. And often what I do with my models is I have that internal monologue going on. Think about what you would do if you were doing a question before you showed it to a student. There would be some stuff that you take for granted that is part of your inner monologue. Again, if we go to that idea of changing a tire, you would know what kind of equipment you might need to do that. You wouldn't say out loud, oh, I need to go get this. Again, the same with the recipe idea. If someone asked me to go and make some bread, I don't say out loud, okay, I need to go and get 500 grams of flour. I know that because I've done it a lot, because I'm an expert in this idea. But my student needs to be able to access that knowledge by me externalizing it. And that comes from thinking aloud. Now, thinking aloud is a really easy idea to just think, oh, I just need to think aloud. But we actually need to think about ways we can think aloud better. So one of them is to practice. One of the most effective things you can do as a tutor is to practice your explanations and to practice them out loud. So just want you to take a moment to reflect, whether you're live or watching this as a recording. When was the last time you practiced, without a student being present, some of your delivery of a model, of something new you're teaching a lesson? If anyone feels happy to share their thoughts and reflections upon this in the chat, please do. But I just want you to take a moment. When was the last time you actually practiced something? I'll give my answer to this in a moment, but I'll just give you a moment to reflect upon this. So, for example, for me, the last time I probably practiced something out loud is I was doing some work towards the end of the year. So a couple of weeks ago to do with year 12 statistics, to do with normal distribution. It's something I've always found difficult to teach, something I've always found difficult. So what I do with my examples I'm going to do, I actually say them out loud when I'm planning a session or when I'm practicing it. I don't do that for every single thing I do. When I'm practicing multiplication with a student, I know my multiplication. I practice that. I'm very happy to externalize that. But this was something that I knew I needed to practice. There's a couple of ways you can practice. You can literally sit there and just speak out loud to an empty room. That is really effective. Even more effective, record yourself. Sometimes you can just use your phone to record this audio of you giving an explanation and then listen to it back. Really effective. Or if you want to push yourself even further, actually kind of do a practice question on the board and record your board or your webcam, however you tutor in that moment, and then watch it back. And what you can focus on is, am I externalizing my thought process? Because if I'm not externalizing that thought process, it's very, very difficult for my student to access that. So I'm just interested if anyone puts in the chat, does anyone ever practice kind of out loud their actual thinking out loud processes? And if so, what have you found works well for you? If anyone wants to put a reflection in, that'd be absolutely brilliant. So a couple of people have just messaged me directly saying, yeah, like I practice them, but maybe not formally. Like sometimes I just do it when I'm like internally in my head, kind of before a session or something like that. That's great. You're still practicing. I'd say it's even better if you practice the actual externalization of that talk. It's a really effective way. You'll just hear yourself saying things. Oh, that doesn't actually make sense when I say it out loud. I know what I mean, but how will my student know what I mean? Another way is to ask yourself, what am I assuming they know? What am I assuming they know? Especially in terms of that expert novice dynamic we've spoken about. There will be times where you know things that your student absolutely does not know, but you make an assumption that they do. Now, this is not an assumption from laziness or from just not thinking about the student. It's just very difficult to remember what it's like not to know things. For example, really nice example of this. I was talking with my son who's 5 years old the other day, and we were talking about an old TV show I used to watch, Robot Wars. For anyone remembers Robot Wars, I used to watch it a lot when I was about 6 or 7, probably. And I was talking about it with my son, and he was saying, "Oh, did you watch it every day?" And I said, "No, it was on once a week, so I watched every week." And this idea was really confusing for him. He didn't understand that I could only watch it once a week at a set time. And that's because I'd made an assumption that he would know. But when I was watching TV growing up, that was it. It was on TV at 6 o'clock, BBC Two on Fridays. That was it. It wasn't on iPlayer, or it wasn't on Netflix, or it wasn't on Disney Plus. I'd made that assumption. And therefore, my explanation to him of how I used to watch it made absolutely no sense to him as the novice. He could not understand that. So it's a really powerful thing. So I'm just going to give you a moment to reflect on an area that you teach, on your subject area. What's a common assumption that you make that you think your student know, and then they display that they don't know? If anyone wants to put it in the chat, that would be absolutely fantastic. Get a good discussion going on there. If in the moment, I'll also give one of the assumptions I am guilty of making with my students. So I'm just going to give you a moment to reflect upon that. What assumptions do you make about your students know? So one assumption I often make with my students, or I'm very guilty of making, is to do with parallel lining shapes. My students, I know they know what a parallel line is. Two lines that cannot meet. I know they know that. They've shown me that. I can see that. But I sometimes forget, if I draw a shape, as I would do here, for example, I often assume they can immediately see that those two lines there are parallel. And that very often isn't the case, because they're so used to seeing parallel lines in that dynamic. That's how they were taught it. So they don't make the connection here that there are still those two parallel lines there. But I, as the expert, I make that assumption. It's very hard for me not to see those as parallel lines. So that's an assumption I often make with my students. And also ask yourself, is my language accessible for them? We're all guilty as experts of using language that we, linked to the previous point, assume our student completely and fully understands. So, for example, in an English lesson, if I was talking about a soliloquy, And I'm talking about soliloquy and I'm explaining to my students, and I've made an assumption that they understand what a soliloquy is, that that language means something to them. Or I, again, in an English lesson, use the word sonnet. I start talking about sonnets. And I haven't thought about whether my student instantly knows what I mean by a sonnet and kind of the inference I'm making immediately from that. Again, if you were teaching history and you said something like the Bronze Age, have you used a phrase that is accessible to your student? Do they know what that is? Because you now may do some absolutely brilliant content on that, but your student hasn't kind of got that anchor system of what actually the Bronze Age was. So where's the link to that? This is especially true if you're working in subjects which have really technical language that we are used to using as experts. I can think of plenty of maths, as I'm sure the maths teachers watching this can think. But in art, we have lots of technical language. In geography, we have lots. Physics, almost every subject has their very specific technical language. And we need to ask ourselves, is that actually accessible to our students? So I'm going to use an example here. So how do you turn on a laptop is the question I've put on the board. So we're all muted here. So I'm going to give us a little task on this. So what I would like to do is I would like you to try and explain out loud. So if you're watching this as a recording, you can pause it. If you're watching this live, everyone's muted at the moment. So we're going to go for this. I would like to try and explain, how do we turn on a laptop? And I want you to do that out loud. So I want you to try and talk right now. I'm going to give everyone some time to talk out loud to themselves. You're all muted, so go for it. How do you turn on a laptop? Can I give you about 30 more seconds? Okay, so most of us there have hopefully spoken out loud about how we turn on a laptop. And now when you're thinking back to your explanation you just gave, and I just want you thinking, have you made any assumptions about what the students know? Or have you used any language that you may have thought was inaccessible to your students? So just want you reflecting upon your explanation of how to turn on a laptop. And I want you thinking about what the assumptions you made that you maybe made that they know, and was your language accessible? And again, I just want you to put any reflections you have upon this in the chat. You can message me directly, as some of you have been doing, or put it in the general chat. If you're watching this as a recording, just take a moment to just write down any thoughts that you have about any assumptions you made. I'm going to talk about my explanation, the assumptions I made when I first did this task a while back. So one of the phrase, the classic one for this is, how do you turn on a laptop, is people say, press the on button. Press the on button. That's a classic, absolute stone cold classic. Press the on button. Do they know what actually the on button is? If you've got a laptop in front of you in the moment, actually look on your keyboard. Where actually is the on button? Does it say on it? Because mine doesn't. So have I made an assumption what they know? Have we made an assumption that the student owns a laptop? Have we made an assumption they actually have a laptop? Most of our students probably have tablets, and maybe some of them have never even used a laptop, because in class they may be either using tablets or computers. I would say the majority of schools have laptops that they just give out to every students. So someone's just said in the chat as well, like, do you actually know what a laptop is or for? Have we assumed they know what it happens when a laptop turns on? Have we said to them, you'll know it's on when you see this screen? Have we defined what actually on means? Is it as it's just turning on as soon as a light comes on? Is it as the screen is on? Is it when I'm actually using it? Have we made all those assumptions? What about if the laptop has no power, hasn't been charged, and we're explaining to our student how to turn the laptop on, and they're doing what we're saying, they're pressing that button, but nothing's happening? They're then going to be confused, like, what's actually going on here? You told me this is how we turn the laptop on, but nothing's actually happened here. Or maybe you've used really technical language, like it's powered up. Maybe that's not technical language, but has it started to power up? Well, I know what, if you said to me, has your laptop powered up? I would know what you mean. But does my student know how this? And then to go back to a point that someone made in the chat and I previously made there, like, what student are we actually teaching? Are we teaching a student who has their own laptop? Or are we teaching to a student who has never even seen a laptop, doesn't have any technology in their house, is on their phone while they're having their tutoring session? These are all little assumptions that we've made about our model. Just reading a couple of comments in the chat. So someone's raised a really nice point that this idea that we're talking about here kind of goes all the way up. So when someone's used the example of teaching postgrads, applied stats, what it's all about. And maybe they don't really know what stats are actually for. Sometimes they don't really understand what statistics as a notion is about. And so we say stuff like, the example in the chat here is like, oh, I'm going to do some stats, as if it's a single moment in time. So that's a really good point. We often do things in our teaching that we forget that our student doesn't have any grounding actually in. I would normally refer to this as kind of where the knowledge is anchored in our brain. If we're talking about kind of the bodies of knowledge, what's it actually anchoring to? If I'm trying to explain how to turn on a laptop, but my student doesn't have the anchor of what a laptop is, that knowledge hasn't got anything to hold on to in the brain. So has anyone got any questions there? We've been talking for a while now about kind of the importance. I'm wondering if anyone's got any reflections or questions specifically about thinking aloud, what I've been talking about in the last section there. It's such an important part of what you do as a tutor when you're working with your students via Tutorful. So just have a think. If anyone's got any reflections, I'll just wait about 30 seconds if anyone puts a reflection in the chat or anything like that. Or any questions, I'm more than happy to answer any questions about this as well. So a really good question that someone's just sent me is just like, how do I know the level of my students' understanding before I give my explanation? Now, this is where your questioning technique, which we spoke about in the previous webinar, can come in. We can do some questioning before we give our explanation. So for an example, in one like this, I would maybe say to, in the question about a laptop, I could give them a multiple choice question showing 4 buttons, and I could say, which of these is the on button? If my student gets that right, then when I do my explanation, I say, press the on button. I'm in good stead. I know they've got that grounded. But if they get that question wrong, and then I still go into my explanation of, well, use the on button, I know they're not going to kind of make that link. So use your questioning before you use the explanation. Sorry, another question's just been asked. So brilliant, Tom. I'm going to come on to this later on. Tom's just saying, should we ask students to think aloud as well to check their understanding? Absolutely. Absolutely. It's a brilliant way to access what our student is thinking about. I'm going to talk about checking understanding in a bit, so I'll come on to that in a bit more detail. That's a really good question someone's just asked me. Oh, look, it's the next slide. Check for understanding. So within our models, and hopefully you notice here, I'm not talking about models for your subject. You know how to model your great talking. We're talking about ideas here that we can kind of use overall in our teaching. Yeah, someone's just put a phrase, just going back, the speech of like the unknown unknowns. We're trying to limit the unknown unknowns by helping our kind of us access what our student is thinking, and that allows us to take our explanation. So what's really important with checking understanding is what we don't just do is we don't just check for understanding after we've done our thing. So we've done our thing, and then I say, do you get it? That's not good checking for understanding. Checking for understanding is a whole process that goes throughout our explanations. Just talk about what we can do before. We can ask ourselves, what do I need them to know before I show them my model that I've prepared and practiced? So I gave you the example of a laptop there, the on button. If I was doing it in maths and I was doing something with shapes and parallel lines, I may get them to show me what some parallel lines look like and draw them in different ways. If I'm trying to create sentences in an MFL lesson with some specific language, then I need to check they actually know what that specific language means. Or if I'm trying in English to push on their creativity by using punctuation in their work, then I need to check that they've got a solid understanding of what that punctuation is. So I can do that all beforehand, before I go into the model. There's no point me modeling what a rhetorical question is if my student is not confident actually what a question is, or what the question mark represents, or where it goes, or what I mean by the term rhetoric question. And I always try and ask myself as a tutor, have I made any assumptions about what my student knows? It's a really, really good question to ask yourself. Have I made, apologies, have I made any assumption that the student knows? I made the assumption that someone wasn't going to be super noisy outside, so I opened my window. Apologies. That's a really powerful question to ask yourself. You don't have to do that hours and hours before. You can just do, right, start my lesson, right, I'm just about to go next mention, right, just pause for a second, Arthur. Are you making any assumptions that your student already knows something? Let's actually think about this before we go into detail. Okay, right, let's go into it. We can check for understanding during our model. So if I find myself in my model or my explanation using a bit of terminology, I could just use terminology, finish the sentence, right. Just before I continue, can someone explain to me what that word means? Notice how I'm saying, can you explain to me what that word means? Not, do you understand what that word means? Do you understand is that classic question we're used to asking, but it's not really an effective question. A, students will lie because we all lie. Like, do you get this? Oh, yeah, sure, I get it. But also, it's quite hard to understand what you don't understand. So if I'm asking my student, do you understand the role of Thomas Becket in this moment in history? Then they would say, yeah, like he's that guy, isn't he? And they may see that as understanding. I recognize the name Thomas Becket. I know the period of history we're talking about, so I kind of know what you're talking about. They would say they understand, but I, as the expert, would say they don't have the level of understanding I need to continue. And I'm going to explain the key steps and focus in on them. So I'm going to make really plain to my students, this is a key step. I can either do that during the model or post as I reflect upon it. But I'm going to point out to them, they may not have noticed that the key step was this. For those math tutors watching, if I'm doing the subject to the formula question where I have to do some factorization in the middle of it, that's a key step, that factorization moment. My student might not recognize that during the model, but that was the key step. And you can think of lots of examples in your subject areas, especially in kind of art or kind of drama, potentially, where something is the really key moment. And we need to emphasize that to the student. And we can also check for our understanding afterwards. Really nice question to ask. Can you summarize what I just did? It's a really, really nice question to ask. So I'm just going to ask you, you can do this out loud if you're muted, or you can just think in your head. I want you to try and summarize by what I meant by clarify key terminology or notation during the event. So I just want to see if you can summarize that to yourself. Just replying to a couple of comments people sent me in the live session. So little things you can do to check how you check for understanding. You can ask yourself what you normally see your students struggling with. Let's come back to that side. You can check, so ask yourself, what do I normally see my students struggle with? And how am I going to check that they are understanding those key points? So I'm sure in your subject, if you think about the last lesson tool, there's an area where you're like, I normally see students struggle with this. And if I'm aware of that point where students normally struggle, I can adapt my models and my explanations to better deal with that. So if I know my students are often struggling to make a connection between this use of punctuation in a sonnet, then I'm going to make that really clear in my explanation. If I know my students are normally struggling to see poems that don't rhyme as poems, I'm going to make that very clear beforehand that a poem doesn't have to rhyme to be a poem. If I know my students are specifically struggling with some of the language, if they don't know what differentiation means, then I'm not going to continue with differentiation. Gradient would be a classic example of kind of key stage 3 maths. If they don't understand what I mean by gradient, then why am I going to deliver that lesson on gradient when I've got no understanding? And also, use the context that you have with this student. What do I know that this student or students or groups, I know we're mainly talking about one-to-one here. What do I normally know that this student has struggled with in the past? That's the context in which I'm working. So how can I adapt my checking for understanding? So if I know this student often says to me he understands something and then later on struggles with it, how can I adapt my checking for understanding after my explanation to make sure he has proven or she has proven to me that they understand my explanation? Use your experience and your context here. You're experienced, really good educators. No matter if you've only been teaching for 2 weeks, you've still got some experience there. So rely on your experience and your context to help you check for understanding with your students. This is just me giving you some strategies that you can apply in your context. Does anyone have any questions there? So someone's made a really interesting point, just saying students, the point was made with postgrads, but I would argue this is with many students, that they have a tendency to kind of act brainy was the phrase used in the comments, and that it would be kind of losing face maybe to them say they couldn't understand the project. What's a really nice thing to do with this, and this is what you allude to in the comment, is if we ask them to summarize a point, that takes a lot of skills to summarize, because they really have to understand the information and then re-articulate it in a slightly different way. You're not asking them to just reply something verbatim. So someone replied earlier, should we ask the students to think aloud? So this is something that we would call metacognitive self-talk, where we get our students to think aloud and we listen to their thinking process. It's a really powerful thing for a student to do as well, because sometimes they'll say, oh yeah, I completely get this. And then when you get them to actually think aloud through their processes, you can say, well, actually, you didn't mention this at any point. And if you're not saying that, you're probably not thinking that. And if you're not saying and thinking that, then how do we know we're going to get it on the paper? If we're talking kind of like in an exam situation there. So I would absolutely get your students to think aloud. It's a brilliant way for you to access their thinking because you are getting them to externalize their knowledge. It's also really powerful for them to spot their own mistakes almost. So for example, when we go back to the laptop thing, when you were doing that explanation, I'm sure there were points where you're saying actually, that didn't make any sense, but I knew what I meant, but because I've said it out loud, I need to actually question whether I know this. So speaking out loud is always a really powerful thing. Next, I want to talk about kind of be aware of your own bias. And this is building in with our own idea of kind of being the expert, but also because we have practiced these models and we've delivered them several times, maybe hundreds of times, that we might have a bias towards our own models. So I just want you looking at the numbers there, and in the chat, I just want you to put, or if you're watching this as recording, just write it down. What's the rule? What do you think the rule for this sequence of numbers is? And if you could put that in the chat, that'd be absolutely fantastic for me to get an understanding of what you're thinking. What is the rule for that sequence? So people messaging me saying each number is double the previous number. That's coming a couple of times. Each number is double the previous number. One is double one, you get two, double two, you get four, double four, you get eight, double eight, you get 16. That's not the rule here. That's not the rule here. The rule is not double the previous number. So what are you thinking again? What's the rule here? What's the rule here? I'm saying the rule is not double. Or someone's saying is every other number like times in by four. So is the rule irrelevant of the 2a is 1 times 4, 4, 4 times 4, 16. Clever, but not the rule. So is anyone else? I've told you the rule is not double. So what is the rule here? Okay, no one's given me the right answer yet. And what hopefully you're finding here is once we have an idea, so a lot of us thought double. If you see this, you're going to think double. Once we have an idea, it's hard not to have that idea. Coming up with the second rule for a sequence is incredibly difficult because to us all, it made sense that the first rule was double. That's what you've said. So to me to say that's not the rule makes it incredibly challenging for you to try and spot what the rule is. Now, I know the rule here, so I find it weird that you haven't seen the rule. And that's my own bias here kicking in. Because I know this model, because I've done it before, I know what the rule is. I find it strange that why can't anyone else see the rule here? Whereas you haven't seen this before, you see it's double two. So when I say that's not the rule, it's really annoying. And hopefully some of you are starting to get a little bit annoyed that I still haven't given you the answer here. And that's sometimes true for us when we're working with our students. They see something, whether that's an image we're showing them, a technique, a model, a strategy, and they make their own implications about it. And then when we go against those ideas, it can be incredibly frustrating for the student. Not because they're not listening, but because they think they've made the assumption. Okay, the rule is the number is double is bigger than the previous one. That's the rule here. The next number is bigger than the previous number. So the next number could be 17, 20, 23, 16.1. That's the rule I've made in this assumption. But you made the other assumption that it was double, which of course you made. Of course you made. Like I made it when I first saw this one. And that's our own bias kicking with our model. I think it's a really nice example there, something to just be really aware of. It's a really nice one to use with your students. No kind of matter what you're teaching, you can give them rules where they will go into too much detail and you can take a step back. And you have this discussion about how we make assumptions about what we see. Hopefully it wasn't too annoying for everyone. So I'm coming back to this idea of checking for understanding before and after to kind of round this all up. I'm going to go back to the idea of the recipe book. Now, the whole point of these models that we've spoke about is they are a way for the student to access our thinking. So I have a recipe in front of me and I follow the recipe to get an outcome. I maybe made some assumptions about what was going on here. I maybe made some errors along the way, but I followed the thing. Now, when I next come to this recipe, I've got a bit more base knowledge. So I maybe don't need to look at every step and every pitch and watch every moment of the video. I still use quite a bit of this information. And then when I come to this recipe book again, maybe just look at the ingredients and the first step and how I know it's ready, what the oven is set up. And I'm sure you've got recipes that you use where, especially with baking, all you need to do is look at how many of each ingredients do I need and what do I need to set the oven at. I know when I now make bread, when I first made bread, I'd have the book in front of me every single step. Whereas now what I basically check is the ratio of yeast to flour, and then I'm good to go. So these ideas of these models that we're using in our teaching are not something that we do every single time forever. We're talking about when we're modeling new information to our students for them to access it. Now, later on in a different webinar, we're going to talk about scaffolding, which is where we take this model and we slowly adapt it to help our student longer term. But I keep coming to this idea of how you use a recipe book. I think it's a really nice way to think about how you engage with models and explanations. For me, this is one of the most powerful quotes in kind of education. That learning happens, this thing we want our student happening is when our students think hard. So our models are meant to get our students thinking hard about the things we are doing. We want them cognitively engaging with our processes, but we need to be aware that we are the expert. And there will be things that we do, things that we say, things that we write, things that we draw, do we assume our student completely comprehends that maybe they do not? And it's much better to check for understanding beforehand than to do our model the same way every time and hope the student makes the inference we are making from it. So we have this idea that we spoke about in previous things, that the learning happening is what is going on inside the student's head. The problem with that is we can't see inside the student's head. We have to make assumptions about what they have learned from what they have shown us. But we can help with that process by adapting our modeling process to give our students better chance to access the process. And we do that by thinking aloud and for checking for examples and being aware of our own bias when it comes to showing models. I think models are so important for us as tutors, especially when we're working with a student who has come to us saying, like, I didn't quite understand this in class today, for example, which is, I'm sure, what a lot of us experience as tutors. But what we can do is we can use models in a way to help the student gain access to our thinking as the expert. It's about getting my knowledge out there. And I don't just do that by writing or drawing or speaking. I do that by a combination of those and being aware that I'm the expert. So I think it's a very powerful thing for you to say to yourself, I'm the expert in this modeling process and I need to be aware of that. The key takeaways I will hope you are taking away from today. And just as if you've got any questions, feel free to put them in. We're going to have some time for questions at the end. The expert versus novice. Buy into it. You're the expert. Be aware of it. And externalize your thought process. How can your student access your knowledge as the expert if you aren't externalizing it? So if you're an art tutor and you're doing some sketching, talk about why you're using that sketching technique, how you're positioning your hand, what type of resource you are using and why. Your student may not necessarily know that. If you're using a protractor in maths, explain to the student how you are using that protractor. It needs to be really clear. If you're annotating a poem in English, don't just assume your student will know why you're underlining and drawing lines and drawing quote marks and highlighting certain things. Explain your process. If in history you make a link to a different part of history or a different person in history, don't assume that your student will also be making that link naturally. You may have to externalize and explain it. And my final tip for using models is to just keep asking yourself, what assumptions have I made about my students' knowledge? What am I assuming they know? And how can I get them to prove to me that they know that? We really don't want to make assumptions about what our students know, because all our students are coming to us in a different moment in time. We want to meet them where they are. We don't want them trying to catch us up. We need to meet our students where they are in their educational journey. That's my final top tip. So if you've got any questions, I'm just going to talk about a couple of other things, but if you've got any questions, please feel free to put them in the chat or the Q&A. I will answer the questions in a moment, so please put them in. So I do have a couple of freebies for everyone on this call. I run a WhatsApp group where once a week I share a video about a tutoring tip, something you can bring into your tutoring. I do that with someone called Andrew Gatsby, my colleague. They're all backed by research, and it's not a chatty WhatsApp group. It's literally we post a video, but no one else can kind of engage with that chat, just to limit the amount of notifications. You can then engage with us in other ways. There's a WhatsApp group that you can scan on your phone. I'll put that up again in a minute. I also have a podcast called Tutoring Tips, where there are around 50 tutors who are from around the world at different stages in what they do, who have shared a top tip about what they do and a top tip for you as a tutor. It's a completely free podcast. They're only 2.5 minutes long. They are literally just, hi, this is my tutor and here's my top tip. And there's some absolute fantastic techniques in there. If you want to learn more about me, best place to go is on LinkedIn, which is the scan top right there. But if you scan any of those phones, it will either take to the WhatsApp group, to the podcast, or you can come and talk to me on LinkedIn. But I really want to thank you for taking the time out of your day to join this webinar today. This is a whole series from me, Arthur Moore, with Tutorful over this summertime, where we're talking about various techniques of cognitive science that can help us develop as tutors. We've got about 5 minutes left. So if anyone has any questions specific or about your subject, or not specific about this idea in general, or anything that you want explained again or in more detail, please let me know and I will do my best to answer them. But I really want to thank you for joining the call today. It's been absolutely really, really interesting. Okay, so a couple of people just typing and some very nice comments. Thank you very much. So how much should I practice my models when I'm practicing out loud? So it's a really hard question to answer. I suppose it depends on how experienced with you are, especially if you're doing stuff for the first time. I would definitely be practicing it and then iterating it. By what I mean is practice and record yourself doing it, whether that's as audio or video, and then watch it back and try and do it again better. And then also, when you do it with a student, be really honest with yourself in your reflection afterwards. What did I get right? And what could I do better next time? And I'd be really honest with yourself in that conversation. It's something I still do after every session. I just take a few moments to just think or write down, like, what did I explain well? And why did I explain it well? How do I know I explained it well? And what didn't I explain well? How do I know I didn't explain it well? What did the student show me? And what can I do better next time? And it doesn't matter how experienced an educator you are, that iteration can keep going. You're going to keep doing that again and again. So I would see it as an ongoing process rather than I do my practice, then I'm all good. I think that's a really interesting thing to say. Someone was saying, at what point do we stop being a novice, and when do we go from a novice to an expert? So I was talking about in terms of the dynamic that one person here is the expert, one person here is the novice. So when you're tutoring, I think that will almost always be the case. What we can talk about is our students who become closer to being an expert, they have that knowledge already there. So if I take my year 11 student and I talk to them about addition, you could talk about them as experts in that area of addition. So I can take that as kind of a given. I don't need to keep going back and be like, remember 1 + 1 is 2. They've kind of become experts in that. But expert is one of those things where you become an expert and then you become a novice in something else. You become an expert, you become a novice in something else, and that line is always moving. So you are never an expert, and you are never just a novice. I would always think about it in this dynamic: who's the teacher, who's the student, and who's the expert. Who's the expert in that dynamic? Obviously, it should be you as the teacher. Some really good questions though. So thank you to everyone who interacted. But someone's saying, can I use that the sequence I did with my students? Absolutely, go and use it. It's a really nice way for them to show like their bias towards their initial ideas. Something we do, I work a lot with kind of English tutors on, is helping them get their students to kind of not take their first idea as the best idea. And sometimes the best way to do that is to show our students that our first idea is quite hard to get rid of. And once you become aware of that, you become better at getting rid of it. Anyway, I hope that was really useful for everyone. If anyone does have any further questions, please let me know, or you can jump on LinkedIn and message me on there. Always happy to talk anything about tutoring. I also have a newsletter on there where once every couple of weeks, I write something about tutoring from a pedagogical perspective. But have a lovely afternoon, everyone, and enjoy the rest of your day.